Cool. So let's just get this started. Whoever's joined, I'm sure people will trickle in. This is an event from the Rady Technology Club. I am the president here with Aeshah, who is the president-elect coming in. We have some awesome speakers tonight. We have Dalton, Varney, Arun. Sorry if I hurt your name, but it's Ragothaman. And we have Clint Deygoo here, all to joining us. Dalton's going to be the first speaker tonight, actually an alum from Rady. He is a self-professed, somewhat computer software engineer, entrepreneur, as well as a musician. His band is 40 Feet North Rock and Roll, if you guys want to look it up on Spotify. He is enthusiastic about computer vision, which I've been looking into lately, but it's he's going to share a little bit more about that. But anyways, Dalton, feel free to take the floor, give us any trends you want to do, talk about, as well as, he's going to do a demo a little bit later. So let's all just be grateful and learn from Dalton and see what he's got to say.
Awesome. Thank you so much, David. Yeah, thank you for having me. I've got some slides that I'm going to prepare here, and I'll present them to you, and including a live demo, as David mentioned. So I'll demo some computer vision technology that alwaysAI is working on, as well as talk a little bit about the market, and just broader things that we're seeing. So here, let me share my screen. All right, you should be able to see my PowerPoint now.
Perfect.
Sweet. All right, so hello, I'm Dalton. So today I'll be talking about unleashing computer vision on the edge. So I do basically corporate strategy and business development for alwaysAI. We're a startup that's been around since about 2018. We've raised 2 funding rounds, and we're basically looking to provide computer vision and software and artificial intelligence to business owners internationally, and really make that process easier, so they can actually leverage that for their business to do things like increase revenue, reduce costs, in a wide variety of verticals. So just a quick overview about what we'll be talking about today. So first, I'll give an intro about myself. Second, we're going to dive into what is computer vision. Then I'll do my demo, which is basically a pose estimation demo. So it's kind of the basics of looking for arms and body parts, and I'll show that, and it'll be live, so it'll be exciting. And then we'll talk about alwaysAI and how we're actually using computer vision for Bitcoin. Computer vision for business, and then finally we'll talk about Bitcoin. That's a joke. We won't talk about Bitcoin. That's all I hear these days is crypto. So don't worry. No Bitcoin in this presentation.
About Dogcoin.
Yeah, exactly. So who am I? Right. So I'm a Rady graduate from 2020. So I just graduated last June, right in the beginning of the COVID pandemic. Luckily I'd been working an internship at alwaysAI before that. And so I was able to basically transition to lead their corporate strategy and business development efforts. So that's what I do now. My education, as David mentioned, basically my bachelor's degree is in computer science from Pitzer College. And I'm heavily focused on entrepreneurship and deep learning. And I really enjoyed my time at Rady, so it's great to be back and presenting. And up here in the top right, you can see this is my first professional headshot that was taken at the student lounge at Rady. And right below it, you can see this is what I was sending to employers beforehand. It's like a glorified mugshot, really. So Rady helped me out a lot, and I'm really appreciative to be back and presenting to you guys. So let's dive right in, right? So I'm going to provide a general overview of computer vision. We get this question a lot. It's computer vision really means a lot of different things, but fundamentally it's a subset of artificial intelligence, right? So that means we're pulling analytics, we're pulling metadata, and really trying to get a meaningful understanding from an image or a video. And so you can imagine these videos could be things like security cameras in a mall. They could be cameras on a drone. Really quite a wide variety. And the goal is to use that information from that video to actually provide either some business insights or to be able to, achieve a goal or a use case that can help, from a business perspective, right? So let's talk about the human senses first. So on the left-hand side, we have, an ear and a mouth, which is basically spoken word, and then actually processing spoken word. And so those are all in the field of natural language processing. And so that's basically, right, you are either communicating something through words, or you're actually trying to understand the meaning in words. So think Siri, think Alexa, even things like telehealth has a lot of natural language processing in it, as well as things like even apps like Duolingo, right? How do you actually convey information through words, through language? And then when we look in the middle, we'll see this eyeball, right? And that's computer vision. That's what I'm focused on. And that's really what my presentation will be about today. And on the right-hand side, we have our other senses, right? So a lot of people think that there's only 5 senses, but humans actually have quite a wide range of senses, including things like balance, the ability to detect temperatures. So those are all really important in artificial intelligence as well. You'll see those a lot on modern day robotics, but we won't focus on those today. So we're diving right into the middle, into computer vision. So before I want to get too deep, right? We're going to talk about the market, right? Because that's what we're focused on, really, is why even spend time in this market? And the real answer is it's huge, right? So over $300 billion in 2021 is the artificial intelligence market, and so that includes everything from hardware to services to software. It's really large, but what we're seeing is a pretty substantial growth. So in NLP, that natural language processing, we're seeing 20% year-over-year growth, and even more in computer vision, right? 40%, some estimate it even at like 44 or 45%. So these are emerging markets that are growing really, really fast, and they're changing like fundamentally everything about our daily lives. And I'm sure you've interacted with some of these throughout your life. Siri and Alexa are really prominent examples. But there's computer vision that's integrated into every iPhone to this day that people don't even notice. There's computer vision in security cameras. Whenever you go to the mall, whenever you go to a Starbucks, for instance, a lot of those are already running computer vision. And so what we're seeing is really an explosion of this market, and it's only increasing in size. And so here I'm doing my little demo before we get too deep. And so this will provide really an understanding of kind of what we do, from a pretty basic perspective. It really helps to see it live, if that makes sense. And then we can dive into, how does this actually enable new use cases for business owners? And what alwaysAI focuses very heavily on is simplifying the process, right? So, as you can imagine, there's a lot of players in this $300 billion market, which include people like Google, Apple, Amazon, Microsoft, these huge players. But what we're seeing is actually, a whole bunch of the small people, regular business owners that own brick and mortar stores all over the country, right? They want to be able to participate as well. They want to leverage those insights provided by computer vision, provided by NLP, but it's just simply too difficult. And so I'll dive deeper into that. But right now I'm going to show you our little demo here. Let's see if we can.
Dalton, quick question. So I'm just curious. So computer vision is kind of like taking a lot of digital data, correct? So where is most of this coming from? Because I read online there's even like drones that they're collecting data from and things like that. So
it depends on who you mean by they. But I mean, it's really like the core of it is you have a camera attached for computer vision, right? So you can see me right here. I'm in my bedroom. This is what I'm doing here is I'm running a super basic demo, which is just we're looking for body parts like the nose, the neck, the eyes, the ears. We're looking for the wrists and the elbows, right? So this is basically out of the box demo provided by alwaysAI. And so this is what our technology enables. Basically, is somebody a store owner super easily could download our software, put this up into their store, and be able to gain some information about what their users are doing. In certain contexts, right? You can imagine, for instance, say, maybe you're trying to understand information about, a tennis player to garner, better analytics about how to hit the ball with the racket. You could imagine tracking, humans as they move through your store and they look at different product displays. Lots of value there. And really, the goal is to be able to make those cameras that you have all over the world, like in those drones, and actually be able to provide insightful data to a business owner. And so the goal is, alwaysAI focuses heavily on ensuring, basically the privacy of consumers. So what we do is we don't actually use any cloud inferencing. So we don't process any data in the cloud. We process all of our data on the edge, in a store location, on a drone. And that's really our main advantage, right? Is basically removing that need to use Amazon, removing that need to use Microsoft. A store owner could buy a device and basically be up and running in a matter of days, actually allowing them to gain that insight for themselves without needing to go to one of the big tech suppliers.
Real quick, could you elaborate on what the edge is? Because I've heard that a couple of times, but I'm not quite sure.
So the edge is actually, hold on, I have a device right here.
Let's see this thing.
Okay, so the edge is basically this, right? The edge is any computer that lives in a space. So you can imagine like the cloud is a data center that's often Kansas. It's like a giant building with no windows where just got some internet wires in there. And then people send, I'll talk about neural networks here in a second. People send, video information there, and they do some processes, and then they return a result. What we do though is we actually use devices like this. We use small little computers, just like your phone. That's an edge device as well. And this allows us to remove the cloud, right? So we don't need to use any of those data centers. What we can do is put our actual neural network, put our computer vision on a computer, and then we can go put that computer in somebody's store. We can put that on a drone. We can actually, put that, actually at the real place where life is happening, right? And then that saves you a lot of worry, right? Saves you a lot of costs from the cloud costs, but it also saves you, the risk of sending data, miles and miles away where it could be intercepted by anybody. You don't even know where it's going. If it goes to, does it go to Kansas? Does it go to the West Coast? Does it go to Oregon? Who knows? So with edge computing, basically we use tiny little computers like this to solve part of that problem.
It's like a Raspberry Pi to me.
Yeah, so this is actually a Jetson Nano.
Yeah.
I've got a Raspberry Pi around here somewhere.
Those things are awesome.
Yeah, no, it's very powerful technology, and it's only just the beginning for a lot of this stuff. And so I can dive a little bit into, what is a neural network. I'm not sure if you guys have any familiarity with neural networks, but here we could start with a simple, diagram basically. So this is a human brain on the right-hand side, and we've got a person playing tennis. And so when you, so basically you have your eyeball, right, with a whole bunch of retinal cells in the back of your eyeball. So as light comes into your eyeball, right, they fire tiny little electrical signals up into your brain, which gets processed by, your visual cortex. And that's, simply a collection of neurons that all works together to solve the problem of what am I looking at? So this is basically what a neural network is. This is what we're trying to simulate, but instead of doing it in the brain, we're trying to do it in an edge device, basically. And so a lot of this technology was actually developed back in the 70s, but the computers were too slow that it just didn't really go anywhere. So what happened is as started getting faster, and people basically innovated to the point where you could stick it onto a board, then that actually allows you to simulate the brain, but on something that's relatively small and low powered. And so what we have here, right, on the left-hand side, we've got this person playing tennis. So if you imagine that pose demo that I showed you, say we want to pull some insights from that person playing tennis, right? We want to map their arms, we want to map their head, maybe where they're looking, where their legs are, to pull some analytics about how does this person hit a tennis ball, right? As well as, you could pull other business insights out of there as well. But so that person plays tennis, and that goes into this camera feed. And so we just got a camera pointed at them. And then what we do is we have these series of what we call input neurons. So these are literal simulations of a neuron in your brain. It's a really small little node, as we call them, that actually computes a very tiny piece of the problem. And so each one of these input neurons, you could say maybe takes in 1 pixel from your camera, and then it sends that to a couple other neurons. And that's this whole middle section. These are called hidden layers of neurons. And so these all work together in tandem, basically to compute a problem. And so this is the deep learning part. If you've ever heard somebody talk about deep learning, it basically means that you've got neurons that are in multiple layers. And so this can get complex really fast. As you can imagine, a lot of these neural networks have hundreds of thousands of millions of neurons, right? And so the key is, don't think about that complexity, right? Basically, just think about this fact that you have an input, the input computes a problem, and then basically you have an output. And so these neurons, they have, a lot of little multiplication that they're doing. They have some addition that they're doing. And then what they do is they all work together with their small roles. And then they actually output a result, right? Which to us will be an understanding. So that'll be something like person. It might be person playing tennis, or it might be the location of the arms and the legs, like you saw in my demo. And so this is a pretty basic overview, but really is, there's a lot of complexity within a neural network. But fundamentally, it's all just a whole bunch of little workers who are, doing one piece of multiplication and then passing it on to the next worker who's doing another piece of multiplication and then passing it on to the next worker. And in the end, you can actually compute really complex problems like understanding if a person's playing tennis and being able to provide, business insights or analytics from that person playing tennis. And I see there's a couple of questions. Feel free to jump in if you have a question, but I'll also answer questions at the end. And I'm nearly at the end here. And so really this is the part where I transition into, alwaysAI, right? So I kind of talked a bit about computer vision. It's a big market, it's growing, as well as some basics about what is it really, right? It's just a simulation of your brain. And so now the goal of alwaysAI is helping businesses build their own computer vision applications to increase revenue and reduce costs, right? It's super simple. And it's fundamentally, we try to allow everyday people, business owners, whether or not they're from Nebraska, whether or not they're from San Francisco, whether or not they own a large company or if they own a small company, right? We want them to be able to make their own computer vision application that's tailored to their needs, and then actually use that to improve their bottom line and their top line. And so this is the part, right, where it's like, computer vision is so powerful, right? A lot of people think vision is our most powerful sense, right? There's things like natural language processing, which is really important, but really the crucial aspect that I think a lot of people spend most of their lives is in their vision, right? And so we see use cases from transportation like autonomous driving, to smart cities, to healthcare, to autonomous robots, to manufacturing. It's really applicable across a wide variety of verticals. And this is why it's so powerful, right? And so, alwaysAI is focused on how do we take all the commonalities with these verticals and condense them into something that we can actually provide to a business owner that they can actually leverage for their actual business, right? For their enterprise. And so here we have a pretty basic example of retail and grocery. So you can see basically what this is somebody's mounted a camera up in the upper sections of their grocery store. And we're getting some basic analytics, right? You can see it's tracking 6 people in there. These people are looking at some oranges perhaps. But you can see, some basic business insights that we could gather is, you have a zone engagement here of 50%. This means that all these 6 people in this frame, they're looking at the oranges, they're looking at the apples, and they're not looking at the berries just across the way, right? And so from a business owner, you install this camera, you get some business insights, and now maybe I need to optimize my berry section. Maybe I should be putting raspberries farther in the back because people just aren't that interested. Or maybe I just shouldn't even sell berries anymore at all because clearly people aren't going to buy berries, right? Simple things like this that you can provide these analytics immediately, right, in real time, as well as you could do things like reducing your staffing, right? So let's say every Wednesday, at 12 p.m., there's relatively few people in the store, so you don't have very many staff, right? And then you have a situation where, a whole bunch of people show up. Maybe you have cash registers that have lines out the door, and computer vision can provide that insight, right? You have 10 people waiting in line, waiting to check out. That means that you need to actually put more cashiers at checkout, right? It's solving really simple problems that otherwise would have required a person to observe, but that you can actually automate now. So you can automate these processes using a camera that's either already installed or, a relatively inexpensive device like this one I have here. What's this process actually look like, right? So alwaysAI, has tried to boil this down into a really simple process that allows everyday people to do it. And I'll show you an example here in a second of what does our platform actually look like. But really, computer vision is so vast. It's so complex, right? As you can imagine, there's tons of academic researchers who are always innovating, creating new algorithms, creating new neural networks. But in reality, a lot of the stuff that we use to provide assistance to our business, I mean, our customers are using things that were discovered in 2016, for instance, or 2018, right? Things that aren't even that new, but they just haven't been exposed to everyday people. So what we do is we start with data collection, right? So you could see this person's jumping a rope, they're hitting a ball with a tennis racket, or they're bouncing, a basketball, right? So this is, you put your camera in a location where you're going to get some really important data, and you basically just collect data over time. So you could deploy this in your store, and you could collect data about, how do your customers move through the store, as well as what are they looking at the most, what are they not looking at. And then what you can do is then you train a model, right? And so we call it training a model. And this basically means you're putting all that data you gathered into your neural network. And then that neural network is going to learn more about your specific situation. It's going to learn more about your store. And then it's going to provide some insights. And so then what we do is we build a whole application around this. So we have this neural network that understands a little bit about your store, but now we're actually going to add a dashboard, right? We're going to add some really helpful insights. We'll even do things like blur faces, right? So we'll add some privacy measures to ensure that your customers aren't actually, their data isn't being sent anywhere. We'll blur faces. We'll do other things like add some bounding boxes, or in the case that you just saw in my live demo, we'll, basically add some lines on my body parts to show this is actually what the neural network is detecting. And then finally, we actually deploy it and gain some insight. And so this is where, the business owners really can leverage their vision, right? Let's say this business owner puts their camera in a store. They follow this process. They collect data, train a model, build an application, and then they deploy it. And so that's the point where now their dashboard is generating useful information. They're getting insights as to how many customers actually entered your store, how many customers exited your store, how many customers are currently inside your store, things like that. And then we actually just repeat the process. So then this is a whole circle, which we just do over and over again, iteratively, to actually get an application that works really well in a situation like retail, or in a situation perhaps like autonomous driving, right? And so this is the part, right, where I plug alwaysAI more, right? So where are we now? So alwaysAI started, in 2018. As David mentioned, Marty had given some talks at Rady. That was how I joined the company. And now I lead their corporate strategy and business development efforts. And so we've had pretty substantial growth. We are seeing use cases, customers in manufacturing. We're working with one of the largest retail conglomerates. We are seeing use cases in autonomous drones, transportation, smart cities. And we've got over 20,000 developers on the platform who've done, more than 5,000 projects. And we've raised a total of $9 million in funding. And so this is, what we're seeing is huge growth in the computer vision market, but there's also just a lot of interest, right? There's a lot of people who want to try this, who want to get it in their store, who want to be able to leverage the benefits of artificial intelligence. And so this is, it all can seem a bit abstract too, especially when, I think that live demo helped a little bit, but, there's a lot of these aspects that are pretty complex, right? How do you actually get a neural network? How do you train it? How do you put it onto a device? And so this is alwaysAI basically provides all of these services. And this is how we support business owners. For instance, we have experts on hand who provide support. And we, have basically a series of technologies that we've built that simplify the process. So you don't have to know what a neural network is. You don't have to know any of this. You can just click some buttons and basically get an application working. And so this is what, what we've built, right? So we've focused heavily over the last 3 years to build these out of the box models, what we call pre-trained models. And so these are neural networks that we've already provided information. So they can do things like pose estimation, like I showed you. They can also detect cats and dogs. They can detect laptops, for instance, or they could do things like that are pretty advanced for autonomous driving, like semantic segmentation. And so that's basically identifying every single car, identifying every single person, street signs, things like that, right? And so we provide this all out of the box, right? There's no customization necessary. You can basically go to our website. It's all free. In case you guys are interested, it's all free. You can basically access all this. And so then what we do is we basically expose, you can see somebody's building a mass detector in this model. We expose a lot of this customization without any coding needed, right? So you can just basically be able to build your own model, right? Let's say we don't offer one out of the box that you're looking for. You can build a mass detector like this person did here. They train their model. That's what that little graph is showing. And then they can actually deploy it. And so here, this video here is one of our customers who crowdsourced data from their autonomous drones. They have these drones that are basically just boats that, they solve things like they just take analytics of the ocean. They'll measure seafloor depth. They'll measure like currents and tides. And so what they did is they asked all their customers to go provide information from their boats, and then they trained their own model. And so now they're actually, deploying autonomous boats, basically, which can do things like detect piers, they can detect birds, they can detect, waves, things like that, right? And it's a really interesting problem, and this one is pretty strange because people don't really think about the autonomous drones that are just like boats that float around, but they're actually really frequently used in docks and bays to make sure that basically the depth of a dock is low enough for a boat to get in and not get basically trapped by sand or something like that. And so what they found was, certain things like birds, right? If you detect a bird, you don't actually want to swerve around it because birds will just fly away. But if you detect a pier, you do want to swerve around it because piers will not fly away. Piers are stationary. And so this is all powered by computer vision, right? Being able to recognize what that obstacle is, and then actually being able to avoid it or not avoid it, depending on, what it is. And so this is a pretty quick summary, and then I think we'll have just a few minutes for questions. Computer vision is growing. It's impacting every aspect of our life. Whether or not you've experienced it before, you've been a part of computer vision. We're seeing use cases from retail to manufacturing to transportation. I'm sure you've seen some examples of Tesla's or Google's autonomous driving, cars that are actually now in cities today. My real moral here is that anybody can leverage computer vision. I highly recommend you check out our website, alwaysAI.co. We offer basically a whole freemium platform, which allows you to just on your computer, on your MacBook, on your PC, whatever it is, you can get an application up and running really fast, and with no coding necessary. It's super fun. You can do things like what I just did, just see your pose. It can detect faces. It can detect people, it can detect dogs, stuff like that. So highly recommend you check it out. And that's the end of my presentation. So let me know if you have any questions. Feel free to send me an email, dalton@alwaysai.co, or add me on LinkedIn. I'm here in the San Diego area and always love to have a chat with anybody, from Rady or not from Rady. So thank you.
Oh, that was awesome. Thanks so much for that. I mean, what an awesome industry to be in, and to think of all the data that's out there. So just to follow up with a couple questions, I saw Guillaume had one. He said, how do you think that what do you think about AI perpetuating bias, and what guardrails are you putting in place to correct for that?
Yeah, this is a really good question and something that's super important, right? I think the thing about artificial intelligence is it will just spit out whatever you provide it, right? So if you provide it biased data, it's going to spit out biased data. And we see this all over the place, right? A lot of companies are having reckonings, right? Even Twitter recently had one where their cropping algorithm, was biased. And so that's simply because the data that they provided was biased. So of course it's going to provide biased data. And I think the thing is too, it's learning, right? And this is how, people become racist or sexist. It's all a learned behavior, right? Somebody instills a value that's not correct or that's biased, and then you repeat it, right? And so that's the same thing with artificial intelligence, right? If you feed it things that are racist, then it's going to spit out something that's racist. And so the key is, the guardrails are really important, right? How do you make sure that all the stakeholders involved, represent what you're actually trying to solve? How do you make sure that your data is diverse? And it's crucial to actually test and constantly iterate and make sure that the results that you're providing are not biased in some manner. I think bias is everywhere. And so the only thing that we can do is just constantly monitor ourselves, constantly monitor our technology to make sure that we're doing everything we can to remove that bias. Yeah, that's a great question.
Awesome. Thanks for that, for sharing that. So does anyone else have any other questions right now? I know we're getting to 6:30. It's about the next time for Arun to come on. But does anyone have any other questions for the presentation? That was an awesome presentation, by the way. I'm still learning about machine learning, and I can only imagine all the data you have to use to train. Guillaume has, I guess he has another question to follow up that. He says, what about the specific examples of, guarding the guardrails? Like, how can you guard against the bias proactively?
Proactively, right? I mean, I think the thing is, I mean, proactively, it all comes down to data, right? As David's mentioning, there's data everywhere, right? And so when you are building a neural network or, for artificial intelligence, right, you have to make sure that the data you're providing isn't biased, right? And so there's a number of checks that you can put in place. But there's also a number of things that, governments can regulate this, right? And I think that this is probably the next step in this question really is, how do you regulate a company that's providing artificial intelligence to consumers and make sure that what they're providing isn't biased or it isn't discriminatory in some way? And so that all comes down to the data, right? That's basically processes that ensure that the data that you're using to train your model isn't biased, and then making sure that the results from that neural network also aren't biased, right? And so that comes down to regulations, really. People are going to do whatever they want unless a government entity steps in and says these are the rules, and this is what should be allowed. Yeah.
Awesome. Great question, Guillaume. Appreciate that. And Dalton, thanks so much for joining us tonight. Really appreciate it. I'll go online and try and make a free account, like you said, mess around with it a little bit, machine learning, a little bit over my head, but it's very interesting stuff. So did make an error. So not Arun, but we have Clint Deygoo, I hope I'm saying the last name correctly, but going to give us a little presentation here as well. And then he is actually from TradeRev. He did work at a few roles before this, some kind of in machine learning as well. So it kind of goes along with what Dalton was saying. And he's actually hailing from Toronto, Canada. He says the weather's amazing right now. So this is that time of year to visit if you want to. And he's an engineering leader, mentor. He works on mobile, web, microservice architectures, and cloud solutions. So Clint, I'd love to have you speak a little bit about what you're working on right now, any trends that you're seeing in technology, and that'd be awesome.
Absolutely. Thanks for that introduction, David. Just going to share my screen. All right. Cool. All right. Hello, everyone. Today, we're going to be talking about some fundamental components that go into scaling software applications. So when we think about scaling software, we're going to delve into what really scaling means and ways that we can get that scaling underway for a system. So what we're going to go over today is, what is a software system? What do I mean by a software system? What is scaling? Scaling the data layer, this data storage part, data transmission, scaling the compute, and then fault tolerance and resilience considerations. So before we proceed, a little bit about me. I'm a software development manager for the core team at TradeRev. And TradeRev is an online car auctioning platform where dealers buy and sell vehicles in our digital auction. Our objective is really to make car sales fair, fast, and easy. The first 5 years of my career were primarily in the Android software engineering space. And then the latter 4 years have been dedicated mainly to building software systems in the cloud. So what is a software system? Really, throughout the course of this presentation, I'm really honing in on distributed systems. So dealing with numerous machines scattered across numerous regions. So tech companies have tons of software systems, of course. Things like Amazon.com, Facebook, they appear as single coherent systems to the end user, yet they're actually made up of thousands or even millions of machines. But these companies didn't start in that state. And that's a key objective here, is to delve into some of the decisions that are in play as user bases increase, going from startup to medium size to large. So let's build a system. This is our basic user, a user initiating a request, getting a response from a system. And what we're going to do here is build out a software system such that it can operate if there are millions of users interacting with the system. So let's change the diagram to indicate that. Oop, there we go. All right, so now we have millions of users over on the left, and then we have our software system. So I threw in a couple basic components for now. We have that gateway component. So let's think of that simply as an entry point. I'm not going to talk too much about that in this presentation. It's really like an API gateway endpoint. But ultimately, that compute service, our system needs a service that processes or computes incoming requests. It performs the bulk of the business logic and knows where to find the data. Think of it as the brain of the system. And then, of course, we need a place to store our data, to persist our data, and that's the database element on the right. So as we go through and change this system, keep in mind that the changes we make are by no means the only way to achieve the results. And that's one of the beauties of this sphere, is really the multitude of possible solutions. So when we think of an application like Amazon.com or Facebook, what are some of the things that we expect as a user? Here are two key things. One of them is availability. We expect the system to be up at all times. The other one is consistency. So we expect like pretty much updates to the system should be seen with minimal delay to all the users. For example, like if someone uploads a new post to Instagram, what is that propagation delay from one of their friends receiving it to another friend? It's not strongly consistent, meaning friends will receive the new post at slightly different times. So let's get into scaling. And it's the ability for these software systems to change capacity based on user demand. And a key requirement here actually is maintaining a certain level of stability and performance during these changes. So whether we're dealing with 100 users or 100,000 users, we don't want the operational integrity of the system to deteriorate. So vertical scaling. This is really increasing the compute power, the technical specs of the machine that we have, that our application is running on. It's definitely an effective way to scale. However, it does have a limit, and that's really that hardware upper limit. There's only so much processing power or memory or storage space that a single computer can scale up to. So due to that limitation, that brings us to horizontal scaling, increasing the number of computers. Now, this does add some complexity when it comes to routing jobs or splitting up the data across these computers. However, the scaling capacity is virtually limitless. So with that, let's delve into the data layer, the data storage layer. So some ways that we store data, databases, object storage, caches, file systems. Now, each of these have, pros and cons, of course, and there's definitely a capacity and speed trade-off. So in this diagram here, you can see at the bottom, the capacities are big, hard drives, SSDs, but their speed is slow. And then as you move up this pyramid toward the CPU, the speed increases. It's more performant, essentially. So things like databases are actually living in the hard drive or SSD world in large part. In-memory caches like Redis or Memcached are in the DRAM section. They're actually like their RAM, their memory. But the only thing about the in-memory approach is that it's volatile memory, so it needs a constant power source to maintain that data, unlike hard drives and SSDs. But caches really do take the load off the DB if used correctly, storing duplicate data there. And if the data isn't in the cache, then the compute server can fetch it from the database. So in essence, the more we minimize the requests to the database, the more performant our system will be. So we'll definitely apply that rule here when we go back to our diagram. We have a single database instance here, but this is not going to work for millions and millions of users, especially considering some of that poor latency we just saw in that diagram. So how about we consider duplicating this database several times so that there are many databases with the same exact data in them for our compute to go to. So in theory, this should allow several concurrent connections to our database data, thereby increasing throughput and ultimately performance. So here it is. We can see we replicated our database. Each of those replicas have the exact same data in them. So now we might be thinking about how does the read and write performance get affected? And it does vary across, like there's so many database architectures out there and it varies. For our purposes, let's assume we're using a relational database here and the reading will be straightforward. All of the databases contain the same data, so all are eligible to be read from. However, writing is a bit different. At TradeRev, we assign one instance to be a master instance. So this master is the go-to instance system-wide for writes. For all reading of the database, we go to our read-only replicas, which is all the other replicas that are not assigned as master. Now we might be asking ourselves, what does this mean when it comes to when data is written? Does it all need to be synced across all of the replicas? And it does. A popular way is an asynchronous approach. In the master, when we perform a write to the master, that propagates to the rest of the replicas, but it's not an instantaneous process. It actually takes time. So going back to that definition of consistency, this actually does violate strong consistency here, because when a write happens, the master gets that write, but some of the replicas might not have captured that write yet. So it's not a consistent system. And this is actually an approach that many software systems use. It's called eventual consistency. So eventually the data will be written to all of those nodes and we're good. And we're assuming that propagation delay is rather small. So this definitely helps. These replicas help. But dealing with millions of users is no easy task. This means that each database is going to store a lot of data. And that can impact response times from the database because we'd be searching through monolithic tables. So let's tackle this. Let's try another approach. Let's add on another approach. And this approach is called database sharding. So in database sharding, what we do is we keep several banks of data. And the key distinguishing trait here is that the data in one shard, say that top bank, would be different from the data in the other shards. So we're essentially segmenting the data to keep our tables of manageable size, allowing us to scale up. So at TradeRev, we actually do some sharding based on region. So we have a database shard for the US region, and then we have one for the CA region. It does add complexity, and it becomes ever so much more pertinent to ensure that schemas are consistent across the shards. Tables should have the exact same schema attributes across the shards. So at this point, I think our persistent database layer is pretty good. However, think about that storage performance pyramid. We don't want to be contacting the database on every request. So let's add an in-memory cache to store recently or frequently used data so that we can intercept as many requests as possible in the caching layer and prevent ourselves from having to fetch from the database. So here we are. We've added a cache. Now, at TradeRev, we use Redis as our in-memory caching solution. Think of frequently landed on pages in an application. The data that populates those pages, we might want to consider storing in a cache so that the performance stays good. So the compute service will be looking in the cache first. If it's not there, then it can resort to going to the database. So it does take a lot of pressure off the DB, and it makes our customers happier. But what about user assets like images, videos, and documents? Where might those be stored? So let's introduce the bucket. So this is an object storage mechanism, really. At TradeRev, we leverage Amazon S3 buckets. If we think about a bucket similarly to how we think about a database, it might present for us like a performance bottleneck. I mean, we might be able to fetch the core data from our Redis cache super fast, but the images might not be as performant in terms of fetching those. Sometimes when you go to a page in an application, the textual data loads first, but then it takes a couple seconds for the multimedia to load. Fortunately, object storage has a caching mechanism of its own, and this is called a content delivery network, or CDN. So this CDN over here in our diagram is a globally distributed caching system for objects. Cloud providers like Amazon, Google, Microsoft, they have their own implementations. And these CDN servers are scattered across the entire world. So when a user initially requests multimedia, oftentimes what happens is that multimedia is fetched from the original bucket location, populated in the CDN cache, which is close to that user's geographical location. From there on out, whenever they fetch those images, it's coming directly from that CDN. So it's faster. I mean, ultimately, caching is a very big subject. There's a lot in caching, and caching is prevalent in all parts of the stack. For example, client-side apps, like say the Facebook Android app, might cache multimedia to the device itself to optimize performance and or enable features such as offline mode. So let's get into data transmission. Some ways we transmit data: REST APIs through HTTP, remote procedure calls, stream processing, message queues. So in particular, let's look at the message queue one. So here's a little animation of a queue, a simple queue. We have a producer and a consumer. The producer is enqueuing a message, and then the consumer takes that message off the queue and actually does some processing. But the key thing here is that the queue stores the data. So like the service or services that consume that data, they can consume the message whenever they're ready to. And if the consumer service craps out or is experiencing downtime, those messages aren't lost. When the consumer resurrects and is operational, it can proceed to consume the messages waiting for it in the queue. So let's keep that queuing functionality in mind as we scale our compute. Why might we need to scale compute? Well, on the data front, we might be okay based on what we've built out. But right now, all millions of users are sending requests to a single compute machine. That machine is going to be overloaded, and the performance is going to falter. So let's apply a similar strategy here. So what we have here is service replication. We would call this army of services a cluster. We can call each of these replica services a node. This is just some like terminology. I'll use them interchangeably here. These nodes are ideally stateless. All of our state and data would need to be handled by our data layer that we created. You might notice that load balancer element that got added. So the load balancer essentially manages the load across those compute nodes. So it would take in requests, determine which compute node to route that request to. And that decision making, there's numerous ways to do that. It could be a random decision. It could be a round robin approach. It could be based on metrics, based on the nodes. There's a whole bunch of ways. Load balancing is its own kind of beast. The number of nodes can auto scale as well, and that's key. We might want to increase the number of nodes during high traffic times and then decrease it during low traffic times. And that would ultimately reduce our cost. So this compute service directly serves our user traffic. However, systems usually need a way to perform background jobs, background processing. At TradeRev, we have background jobs such as bank jobs, which contacts the bank, transfers funds on a daily basis. We also do nightly accounting report generation runs. All of these need to be done in the background. So this offloading of work to the background can happen in a background service. There, we've just added our background service to the diagram. So this is right now, the way I've set it up here is it's just really receiving requests from the compute service, but it can essentially receive requests from anything, from anywhere, any source. And notice how we're using a queue to deliver these messages. This ensures that the messages make it to that background service. If, for instance, the background service is down, those messages would persist in that queue until it's back up. But as you might guess, similarly to the compute service, our single background service might get stressed with requests. So this leads us to a similar approach. So there we go. We've replicated the background service as well. You might notice we don't even need a load balancer here. And this is really based on the approach we take at TradeRev. When it comes to using the queue and consuming off of the queue, we use a polling approach. We poll that queue and then pull for messages. So whichever node sees an eligible message can remove it from the queue and consume that message. So we built out a nice diagram here. Let's talk a little bit about fault tolerance. Faults can and do happen. Errors can and do happen, absolutely. So the engineers must factor that into the architecture. Our gateway entry point looks like a single point of failure here. So that's one thing you want to analyze when you look at a system is single points of failure. Also the load balancer. So this assessment is always critical. Also, you want to think about machine locations. Where are these machines located geographically? What if you're using a cloud provider like Amazon Web Services and their US West data center goes down? In that unlikely scenario, if we build this application to replicate across multiple AWS regions, our application could potentially survive that region going down by routing to instances in the other region. I also want to mention that each of these components are complex software systems in themselves. So the CDN, the bucket, the in-memory cache, the queue, these are very complex systems. But these cloud provider implementations, a lot of that complexity is abstracted away. So to make our system resilient to errors, we should also consider adding circuit breaking, especially if we're dealing with third-party services. So many applications, I can't even think of one that doesn't always interact with some kind of third-party software system. So if we were going to apply to our diagram here, let's look at that gateway, our pretty much our gateway layer that's taking in requests. We can add a circuit breaker there. We can set a timeout value of say 5 seconds. And if the software system doesn't return a response within that time, we break the circuit and just return an error to the user. This ensures that our system isn't in a limbo state and users don't experience extreme or infinite load times. Retry functionality is also another thing we can implement. If we're hitting a third-party service, for instance, maybe the first attempt to contact the service fails. But if we have some kind of retry, which will try it again after like 500 milliseconds, the next try might actually go through. And without any kind of human intervention or anything like that, it's just the system builds in that resilience. So Netflix devised a system called Chaos Monkey, which actually randomly terminates instances in production, purposefully introducing faults. So it's a really, really cool and groundbreaking concept that they came up with several years ago. So this system that they have in place is actually just breaking down nodes at random across their production system. So it's a really fascinating way of ensuring that engineers implement their services with fault tolerance and resilience in mind. So some closing remarks. One takeaway here is that building for scale is a necessity in software systems, particularly as user bases increase. We went over techniques such as replication, sharding, caching, load balancing, queuing, and background jobs. We also looked at ways to improve fault tolerance and resilience. And hopefully, there's some takeaways here that can empower you when you interact with software systems, technology organizations, and beyond. Thank you so much for your interest and your attention.
Awesome. I had a question for you. So I'm guessing TradeRev, are they all in AWS, or do you guys have any in-house storage?
No, we're fully on AWS.
Fully on AWS. Yeah. Wow. So in the past,
we were doing a hybrid approach at first. We were actually a bit in Google Cloud Platform, a bit in AWS, but a couple of years ago we decided to just coalesce everything to AWS.
Wow, that's crazy. And so, when you were at eBay, did you guys also were on the cloud? Or did you ever work with in-house storage, or was it always in the cloud? I'm curious.
Yeah, eBay was an interesting one. Their system, they had numerous cloud systems. Like I wasn't too familiar with the one that I was working within because I was very in tune with the mobile side of things.
Sure.
So in some ways, I was kind of in that sphere. I didn't really integrate too much with like the actual cloud side of things.
It's because the TradeRev is all in the cloud. I think this is just showing an example of where companies are headed. I guess I used to work at a storage company, data storage company, and they had flash storage. The other one did hyper-converged storage, and that's where like the in-house storage is going, where they combine the flash and the compute and all that stuff together to make it really quick. But yeah, it's all moving to the cloud right now. I guess in the Amazon, I guess the Elastic Cloud, something like that. It's
all those services, absolutely. I mean, the on-premises stuff, all of this can be implemented on-prem too. Of course, you have to implement all these components yourself. It would definitely take some money, that's for sure.
Wow, awesome. So, does anyone have any questions? That was an awesome presentation, Clint. Yeah. And also the load balancing, the replicating is huge, right? For your disaster recovery plan, that's huge.
Absolutely. Yeah, redundancy.
Scaling out. Yeah, so awesome. Does anyone else have any questions they want to reach out with? I know that Jeff was asking about RAID or something like that in the chat, and then I think Guillaume answered his question, but yeah, so awesome.
Thanks a lot.
Yep. Thank you. We appreciate it. Yeah. Aeshah, you want to take the reins here?
Yeah, so thank you again, Clint, and special thank you because he is joining us from Toronto, and I just realized it's 10 p.m., almost 10 p.m. his time. So we really appreciate you being here. All right, so we are now moving on to our third and final presenter. We have Arun joining us today. He is currently the Director of Product Development at Intuit. For the core identity platform, Arun's experience spans 20 plus years of building and leading high performing organizations within large companies and startups. He has held various leadership roles in product engineering, product management, and business leadership. He is passionate about building world-class innovative organizations. So without further ado, here is your closing speaker, Arun Ragothaman.
Hey, thanks, Aeshah. Just a quick audio check. Can you all hear me okay?
Yes, we hear you perfectly.
So given that I heard Clint talk about some of the large-scale systems, maybe I'll start from there as a bridge into the conversation. We're going to go from all the scary technical world into a lot of the human people organization world. But just as a bridge, what I do at Identity, and Guillaume is part of it, is lead identity services for Intuit, and we deal with all the problems that Clint talked about on a day-to-day basis. And we handle some really large scale. We handle up to 650,000 concurrent sessions on TurboTax, for example, or we have services that deal with about 200,000 TPS on any given transactions per second on any given day. So we have a lot of fun with some of the complexity that Clint talked about. So let's transition, and thanks for the opportunity. Good evening, everyone. Hopefully, good evening works, and if there are other people from other locations, good morning, good evening, wherever you are at. I'm here to talk about what it takes to build what I call human-centric, high-velocity organizations. Aeshah gave me some background. I'll talk a little bit about it. The picture on the right that you see there. Can you all see my screen? Okay. Yep. Okay. So the picture on the right, this is not made up for the presentation or anything. This is my team from India that I used to lead, a fun bunch of folks. And we implemented a lot of the things I'm going to talk about today. And to some extent, I just wanted to dedicate this talk to them because I had a lot of fun working with the team in India. So just some quick logistics before I get started. Maybe 1 minute. Okay. This is about me. I think the most important thing you need to know about me is I totally dig Karate Kid. I think it's going to be really relevant as you hear about this conversation as we move forward. And if you need another information to determine if you want to stay on for the next 30 minutes, is one of my favorite books is Jonathan Livingston Seagull. In fact, I was contemplating quite a bit on should Seagull be the picture on the homepage or not. And I spent about 2 hours yesterday thinking about it. But beyond that, like Aeshah said, I've done a bunch of stuff. Most of my career has been in India, but I've been working in global locations. I lead a relatively large team at Identity right now, about close to 130, 140 people. And I've also done startups, and a lot of these organizations literally was like ground zero, the first employee to building a team and launching products in the market. So I have experience working in larger contexts, smaller context, leading organization through change, and I'm going to bring some of that experience to bear in the conversation today. And maybe another thing that just a quick information as well is I also do have an MBA, so like I belong in the club, and hopefully we can all have a good chat in the evening. So throw terms at me. This is all a safe place for us to talk about MBA terms, and I'm going to take some liberty with that as well. One of the other thing that's been a huge influence in my life is Buddhism. A lot of this journey I've been parallelly growing in my own Buddhist practice. And if you hear traces of Eastern philosophy in the conversation, that's where it comes from. And for folks in the group who are interested in it, that's a whole new conversation that we can have offline. So setting some context for this conversation itself and what to expect, right? Like think of this as somebody who's been around, has done a few of these things. And this is really just a personal share out of learnings and coming off ideas from a lot of different books and experiments that I've done with those ideas. This is by no stretch of imagination expected to be a comprehensive treatment of this topic or I'm not going for comprehensive coverage here. I'm really going for a few key things that I think is important that I can share based on my experiences through the things I've done. And I'm happy to continue the conversation to the extent there is interest. So feel free to reach out through emails, and I'm happy to engage in coaching conversations as well. Or if you want to bounce off some ideas, feel free to reach out, and I'm happy to work with whoever has interest. Okay, let's get to the talk today. There are three sections of how I'm going to divide the conversation. I'm going to start with anchoring us on what I mean by humanocracy, which is kind of what I titled the talk as. What does it feel like to be in these organizations? Set context on why it's worthwhile to build such organizations as leaders, and then go on to maybe talking a little bit about the specific elements of building such organizations. Maybe a quick question, and I don't know how we'll do it in Zoom, but we'll give it a shot. Maybe people can raise hands. How many of you have experience either managing teams or aspire to manage teams in the future? I'll leave you guys to react, and they'll keep moving forward. That'll be good context as I navigate this conversation. So humanocracy, this is a term I picked up. I still don't quite feel like this fits what I'm referring to in its entirety, but this is the best I could do in a term. Where this really is about designing organizations where you put people in the middle. The question we're trying to deal with here is, how do you design an organization which enables to maximize human potential? You have a lot of very, very talented people in a lot of different organizations. And in my own personal experience, the potential of the larger group is not fully utilized. And I personally feel that's a huge lost opportunity. And I've been working, at least in my own context, very, very hard in enabling environments where people thrive. And when you think about such organizations, right, like one of the, it's almost an interesting question of like, how do you know you're kind of in such an organization? And I almost always joke saying, you know it when you're in one of them, right? And some of the things to look for in such organizations is this notion of flow. And I don't know how many of you are familiar with the concept of flow in the whole operational design, system design kind of concept, but these organizations are extremely resilient. They seem to be able to wade through various curveballs that are thrown at them. There is a very natural sense of cadence around things that happens in these organizations. There is steady velocity, and all of that enabled through collective leadership. So when you walk the floor, and if you were to kind of do a virtual walkthrough of some of my teams in the past, you wouldn't know who the leader is, who the follower is, who's a new person on the team, who's a manager. It just is very, very organic in terms of people stepping up and taking on ownership roles. That's all fostered through a sense of strong community, and enables that strong community and collective leadership enables a lot of innovation and experimentation. So there is this sense of constant growth and evolution in these organizations. And I'll talk a little bit about some of the things that enables that as we move forward in the conversation. So let's start with why. Like Simon Sinek says, right? Like, let's start with why. Why do we take the pain to build such organization? And trust me, it takes a lot of work. My own personal experience had a lot of gray hairs trying to build such organizations. And the simplest way to put it is, it makes the world a better place. It works for you as a leader, as a person. It works for your employees, the people who are part of your organizations, and it definitely works for your company in terms of delivering, outstanding performance externally as well. Gallup did a survey of what they called Great Jobs Demonstration Survey. The question that was asked was, how many people did what they did best, or what they're really good at on a day-to-day basis? And the response positively to that question was less than 25%. Less than 25% feel that they do what they do best on a day-to-day basis. That's a lot of lost potential. And if you look at another good reason to build such organization is the biology of human beings don't support it. If you look at neuroscience evidence, there is a lot of evidence where if people tend to get over-managed, then that seems to trigger the fight or flight parts of your brain. And if you don't engage them in generative conversations, and when they're engaged in generative conversations, contributing to creating the future, the frontal lobe lights up, and that's where you get creativity, innovation, potential, and so on and so forth. Last but not the least, and I don't have specific evidence here, you can go read the references that I have in the book, in the deck. Clearly, these companies seem to perform really well. And one of the aspects of the performance is it's usually multidimensional. It's not just about revenue or safety measures or productivity, innovation. It all comes together. So it's not really just about one particular dimension where these companies do well. Okay, so let's talk a little bit about how we create such organizations. And there are 3 key pillars in my view that enables to build such organization. The first one is what I call the taming system complexity. We'll talk a little bit about system complexity and how it plays in these contexts. The second lever is really about unleashing collective greatness. Think of a question, and I'll get to this question in a bit when I get to the slide in a couple of slides down. But what will the organizations feel like if everyone on the floor felt like the CEO of the organization that they are part of? What does that do to the overall productivity of the organization, the morale of the organization? And we'll talk a little bit about how we enable such a place. And the last aspect is the relentless pursuit of perfection, kind of pushing towards an ideal state. And you probably are starting to see the Karate Kid connection here, but we'll get to that in a few slides. Let's talk about system complexity. Clint just talked about the complexity of services and all this stuff. So let me give you some concrete examples of complexity. Intuit, I'm part of Intuit. I actively work on contributing to making TurboTax available for all the US customers. Close to about 100 to 150 teams have own services that contribute to delivering TurboTax for customers. That some of them are within Intuit, some of them are external to Intuit, and we are hosted on AWS, so that brings a whole slew of complexity around how we deliver to customers. So when one of the problems is that there are different components to bringing such a solution to the customers, and each of them are in some sense evolving independently. And to holistically look at the whole system and see exactly or predict exactly what's going to go wrong is really a hard problem. And the handicap that we have is most of us are linear thinkers, and if you look at the natural, we're educated our way into thinking linearly, and there is a bit of a mismatch in the world that we live in and the way we naturally think. So how do we counter that solution? Enter systems thinking, right? And systems thinking as a concept has been around for a while. It was introduced by a guy called Peter Senge. There's a book again that I have reference to. And the diagram on the left is what is called causal diagrams. So effectively visualize this as, if you were to draw simple causal loops that are in play in any kind of complex system, the net effect of what is going to happen is the interaction between a lot of these complex causal flows. And it's very, very hard to predict exactly how these interaction patterns are going to play out, and predicting system state is extremely complex. So if you live in a world where everything is constantly evolving, how do you build organizations which are resilient to changes that might come from you from anywhere? And one of the generic thinking here is to say, the question that we're trying to answer here is, how do you build organizations that get better with time in such a complex environment? And the way that's done is through a very structured application of a set of processes and set of activities that you do around these learnings. And I'll give a specific example in a bit, but the inspiration for this comes from Toyota. And Toyota tends to do about 1 million experiments in a year. And when you think of experimentation at that scale, where every single unit is constantly evolving, it happens only when you have a fairly well understood methodology, and that's part of the organization DNA. And this is a very critical part, in my view, of building the kind of organization that I'm talking about. Quick time check, I seem to be doing okay. So let me start with a quick example. This is a very concrete example that happened in my team. One of my teams was running into a fair bit of issues, trying to meet their commitments within a time frame. For those of you in software, you'll understand this. This is part of an agile sprint, and the team was struggling with their say-do ratios. This is a set of stories they commit to, or the work items that they commit to within a fixed period of time. And Guillaume is laughing because he's gone through some of this himself. And there's a constant struggle in terms of meeting the commitments that they made. So the way this works is that's the creative gap, right? That's some sense of a creative dissonance between what I expect to happen versus what is actually happening. And that triggers an investigation process, a retrospective process. The first was really just, identifying this as a problem. And typically this comes from the team. That's the recognition of there is something happening here that's not quite where it needs to be and needs further investigation, right? The next step is really around, the team then set up a set of things that they wanted to collect data around to really understand deeply what was going on. And usually when you get into this, you feel like you have all the data that you need, but you immediately realize that some of the specific data that's going to be truly material, you don't really have. And then the team set up some processes to collect the data. And in this particular case, they expose their estimate data around where the engineers were spending time. This typically tends to be very sensitive in software environments, but the team kind of volunteered to share that within their team and look at what was actually happening. Once they had the data, they implemented what is typically called 5-eye analysis and deep retrospective to truly understand what was happening in the system. And coming out of that, identified a set of root causes and constructed experiments to counter the root causes. They then went on to do their own experiments within the team, isolated a few best practices, and then ended up teaching the entire organization those practices, or they made changes to the standards that enabled us to scale out the learning across the entire organization. If you see this life cycle, it started off with a very simple problem. It went deep into understanding truly what was happening in the system. It translated into a set of best practices that was experimented with to be proven. And then it was scaled out to the entire organization. And typically, the way these things happen is, when you have this working at scale, you can really do, hundreds of such experiments in any given context, and it's effectively 100 different ways the organization is getting better. And the leadership role in these contexts changes from being the person who knows the answer to effectively being the teacher who's teaching the organization to do this in a structured way at scale. So effectively, the leader's role becomes teaching, facilitating, and building the organization skills and doing this steps effectively. So that's about taming system complexity. I talked a little bit about what system complexity is and what are some practices that you can have to effectively combat complexity. The whole iterative nature and the continuous evolution process is a very integral part of managing system complexity. The next pillar is what I call, and this is a term I borrowed from, again, one of the books, it's Unleash Collective Greatness. And the question I raised a few slides ago, how do you get to a point where everybody on the floor thinks like the CEO? Sometimes I feel in my own personal experience, autonomy, we all know autonomy, and we've all heard the talks around mastery, autonomy, purpose, and how it lights up everybody. But one of the, sometimes autonomy tends to get misconstrued to meaning like everybody can do their own thing. In my perspective, autonomy is not about like everybody doing their own thing, but it's really about everybody on the floor thinking like the leader of the organization and pushing the organization forward. And to enable this, there are two key things that needs to happen. One is clarity on shared understanding across the entire group on what is important, how you make decisions, what is acceptable, what are the behavioral norms, what are the values. So effectively what you're trying to get to is every single individual in the organization understands and behaves as though the CEO would be operating in his situation, in his local context. The second part of that is competency building. You can, when you start, part of this is about enabling everybody, getting more responsibility, delivering outcomes for the organization. And when you enable that, you need competence. And usually at the beginning, when you start doing this, you run into issues where people are not quite skilled at doing what they have to do. They don't understand what outcome ownership means, what it means to think like a CEO. So there's a fair bit of coaching that needs to happen to develop the competence that's necessary. But if you have the two pillars, then you can seed control, push decision making to where the data is, get everybody to think like leaders, and then the leader gets to take vacation. So one of the things I think about of my role is really about making myself redundant. The question therefore here is like, what do I need to enable, or what clarity do I need to provide the organization so they can make the decision that I would make in their context. Okay, and one aspect of ceding responsibility and getting people to step up to additional responsibility is psychological safety. The first time you do it, you probably are not going to do it correctly. You've all seen this at home when some of you may have kids, and when you have kids and you give them responsibility, the first time you give them, it's not going to happen. And if people get penalized for that fact that they tried something and they didn't quite make it happen, then it doesn't quite create the environment where people will take risks. And to enable that psychological safety, you need community. You need the support from your peer set. You need the sense of belonging and kind of commitment to that individual success. And another important element of that is really where you look at organizational construct, you look at the opportunities that the organization has, and look at how do you enable those opportunities for a particular individual to meet his own personal goals, or personal true north goals, as we call it. So it's really a very active sense of enabling the individual to accomplish his own personal goals while working for the organization, right? And when you create that magic, there is a magic portion that happens. In my case, and I can give examples. We had conversations with people where every single person on the floor had a career development plan. We had mapped out for the next 18 to 24 months what their personal goals were, how the organization would lean and create opportunities to help accomplish those goals. And what that leads to is a sense of comfort, a sense of internal safety and balancedness around how you think of your role in the organization. And that tends to create a lot of space for others as well. And you get to a place where you lean in because you're in a good place, you start helping others, and it creates a virtuous movement across the floor. The last leg is what I call pursuit of perfection. And like Michelangelo calls the main end of art is perfection. And when I talk about pursuit of perfection here, I want to focus a little bit of the spirit behind it. There's a lot of mechanics and the tools and the techniques to do this, but maybe for the time that we have, I just want to focus on the spirit behind it. This is not in the sense of I'm going to get so better that I'm going to be better than everybody else, and the whole notion of competitive excellence. And there's a little bit of that, but this is not really about that. This is really about pursuing a craft to the end, the belief that there is always something better that can be done, and pushing toward the ideal status. An example of this I've done with my team was, I challenged my team to say, why should there be defects in software? Defects in software is a well-accepted term. It's an industry thing. Like everybody expects that software will have defects. But we started this conversation around why should we have defects in software? And that led to a lot of different conversations, which led to a lot of different practices that we incorporated in our team. And we were able to dramatically reduce defects in the software that we were producing. Right. So that's just an example, but when you really put something out there that is inspirational, the creative genius of the team comes together, and you start doing things, challenging status quo that you wouldn't otherwise challenge. So that's the pursuit of perfection. So just to close out, there are 3 legs I talked about: taming system complexity, unleashing collective greatness, and the pursuit of perfection. Just getting to the last part of the conversation, just concluding, this is typically a journey that I would anticipate any team to go through. This is what we went through. Usually it starts off for some kind of a team. You take on a leadership role. There is no clarity. There is no well-established set of values. It starts from there, right? And then the first step usually is about establishing clarity, aligning on the value system as a leadership team, clarifying that for the entire organization. That usually leads to confusion. People don't buy into it. They don't think it's the right thing to do. Sometimes they don't truly understand it. So there's a lot of confusion that it entails because you've suddenly defined something that people may not have fully internalized. I think one of the key things that I think the first few steps I talked about, most organizations do. The one thing that I've found, and this probably is a key takeaway from this slide, is the deliberate organization strategy to deal with the confusion and getting it to clarity. It's a very, very structured process where you have a very clear, we talk about product strategy quite a bit. We talk about company strategy quite a bit. I haven't quite seen enough conversations around organizational strategy, even within, great organizations like Intuit. And my view is that this is the key thing that enables organizations to get better, but there needs to be a very, very concrete execution plan to make it happen. And in my own context, we created an organization strategy where we had clear roadmaps, clear outcomes that we were shooting every quarter for like 6-8 quarters before we get to where we want, before we got to where we want to get to. And once you start seeing the results of some of the organization strategy paying out, you take some early wins, and that's all party after that, right? Like you see the wins, people get behind it, and then there's the virtual cycle that starts off. One thing I did want to throw out there is, usually I've surprised myself at how much ownership the team took and how much they stepped up, and the rate at which the organization moved forward once we got the organization to a certain place. So you'll be surprised at how much throughput you can get when everybody on the floor is energized. All right. And a last leg of this conversation is to enable all of this. It particularly needs the Karate Kid leader, right? This is not about knowing all the answers, leading with the answers. This is really about facilitating the team getting to their own answers, and it needs, in my view, a certain style of leadership. Importantly, follower-first leadership, being there for the team, and it needs a lot of patience. This takes a lot of work, and for somebody who's in the mold of this continuous improvement, and you love that process of making small improvements and continually learning about yourself in the process, this is a phenomenal thing to do. And in my own personal experience, it's been very, very fulfilling. So I said I'll get back to the whys when we started, and this is my last slide. One of the things that, one of the big whys of why you should do this, and all of you, depending on where you are in your career, I still think it's a worthwhile investment of your time to focus on some of this, is the personal fulfillment side of it. I've been around for a while. I've had some wins. I've scored some points in my career, but the most fulfilling moments have been the ones that these comments I've got from my team. There's actually feedback from my team of some retrospectives that we've done and capturing their experience working in the teams of some of the teams I've led, right? And when somebody writes to you saying, thanking you for life-changing experiences, trust me, it stays with you much longer. It makes you feel more fulfilled than any amount of points you might win or any amount of external outcomes that you can drive to. So that's my pitch. Hopefully you'll take some of this conversation and experiment. But that's all I had. Thank you for the opportunity, and happy to answer any questions.
Thanks, Arun. I think when we think about technology, we certainly can't forget about the human element, right? And so this is an amazing presentation, helps us navigate that. And also this comes at a perfect time. I know my cohort especially is joining or going to organizational strategy next quarter. So we're already going into that course with additional tools, thanks because of this presentation. So thank you for that. Do we have any questions from the audience?
Yeah, I have a question. So I'd say, Arun, what's a conflict that you've seen when managing a team? Because I know that attitudes can kind of be infectious, correct? So what's an example of maybe someone who is not happy to have the job and then causing a problem, and how you overcame that, or any type of kind of social conflicts? I know it sounds awesome from your perspective, like you've had a lot of triumphs, but what's an example of you kind of having an obstacle here socially and overcoming that, being a leader?
Yep. So I'm trying to hold off from philosophical answers. Let me get very specific about, if you look at fundamentally understanding why people are at conflict, right? At the end of the day, everybody wants to, there are a few common elements of anybody in a team or any individual, right? They're trying to be happier. They're trying to, do well in their life. So the most bit my read is, and that's where I start with most of these conversations, is most people's intentions are in the right place. Most, not all, most, right? And to that extent, in most of these cases where there is a problem in terms of the person fitting into the mold of the organization that you're trying to create, there is usually some kind of a value mismatch, right? or some kind of an alignment mismatch in terms of what is the right thing for individuals and what is the right thing for the organization. And in some cases, it's appropriate for that to branch off. And I've had successes on either side. And I would term the success as where you accurately recognize that problem and deal with it. And the solutions that could be the individual understanding that and finding enough value in being part of the organization and growing. Or it could be about saying, this is not my thing, let me go do my own thing. And I've had both of those examples, and it's about having an honest conversation about that as a leader with the individual. But typically my read is, force doesn't work. It's not about, if you get into a ego hassle where you're trying to prove you're the boss and somebody else is your kind of follower and thou shall follow my instruction. I personally don't think it ever works. So it needs, the first thing is to be understood, right? So to learn and understand, and usually, it comes out very, 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 very clearly on what is the problem and what you can do about it.
Absolutely. I think kind of aligning interests, like you said, like goals, that's huge.
I have a question. So, as a leader, you certainly get to decide how you want to approach, your approach for the team. And it sounds like you've done a lot of research, this approach, and it's really working for your team. Do you share this with other leaders? And that way it can have this ripple effect? Or do you feel like leaders are kind of stuck in their own mindset of what they think is best for their team?
I think a lot of, one of my things with this, and Game, you can maybe share because you've been around as well, but I don't think this is a binary thing of, okay, I've come up with this thing and nobody else is doing it or whatever, right? It's the intensity and the passion and the commitment to push to that edge case is where I think it varies quite a bit. So there'll be usually pockets of some of this that I talked about that's in most teams. But I've seen like the push that I do in terms of my commitment to this process is a little higher than some of the other folks I've worked with. So I've shared this with a lot of different people. I've, most of the people who worked with me as part of this process, they've gone on to lead bigger teams now. And in fact, as part of this presentation, I talked to a few of them. And, I was showing them the slide of, okay, this is the journey we went through, what do you think? I said, oh, that feels like you've captured what I'm going through, right? So there has been successes that way, as in I've scaled out through people who've been with me. I've also coached some external folks through this process, and they've had some wins through this as well. And I'm usually sharing these ideas in my peer set. The mileage of how much you kind of dedicatedly apply this in your group versus how much if you think like, okay, you have your own kind of leeway for how much you want to go in this, that varies. But one of my perspective is you get the most value when you push for the edges. When you really push towards that ideal state is when you get the most value. And I feel like the effort it takes to push towards that is higher, but if you push through it, it's a good long-term game and you get a lot of outcomes through that. But it takes a lot of effort as well. So it's really a question of what's your mileage.
Yeah, thanks for that. I think, we have a lot of young leaders here, so that's a really good approach of pushing your boundaries. So thanks for that. Do we have any other questions in the audience?
Throw in a couple of comments how it feels to be under this kind of leadership, since that's my reality. And one of them's around like seeing it in action. The number of meetings I've been with Arun where like we come and we're like, we have a problem, help us. And he's like, well, what are you going to do about it? And really pushing and telling us basically that we're the ones in control and we're closest to the data. And so we need to have our recommendation and solution that we'd want to give. So I can't count the number of times that that's happened. And even on a personal level of like trying to instill leadership of trying to like scale our like agile practices throughout this now identity organization and kind of leading that and providing that input of like books, resources, all this kind of context. So it's been a fun journey to be along.
Awesome. I will say it was quite fun watching Guillaume's interaction or his face when you were presenting, because I think that was really him confirming what you're saying. So that was awesome to see.
Guillaume has been at the receiving end of some of this, but hopefully it worked for them. maybe, I know probably we're out of questions and I know it's a Friday evening, but one thought I will leave you guys with as you navigate into your leadership journey. Think about if all your employees were volunteers, how would you lead? Right? And then we tend to assume a lot of constructs around power and control and all this stuff, but the day where your employees can volunteer to do the things that you want them to do is the day you've accomplished alignment and success. In my view, that's the way I think about it. I think it's a good true north to push for, and if you get anywhere close to this, your team is going to have a lot of fun.
That is a great way to close it. Awesome. Yeah. So we are at 7:31. I want to say thank you to all of our speakers. Clint is still online, so thank you. Thank you, Arun. We really appreciate you spending your Friday evening with us. A lot of us really appreciate your insights and your experience. So thank you. Thank you. I'll hand this back to David for any other closing remarks.
I think that's it. That was inspiring and awesome to hear. And I think everyone who spoke tonight, I learned a lot. I think everyone did. And this is also going to be recorded and put on YouTube so we can all go back and watch it if we want to get some more inspiration from people like Arun. But with that, yeah, I think that everyone have a good evening. Thank you for joining us again, and we really appreciate it. So that's all I think we have to say.
Thanks, everyone.
Thanks, everybody. Good night.